Hi, today we're going to be doing or starting the tree implementation. So we're going to be doing a linked binary tree and a linked binary search tree. And then we'll be doing a heap after, which is just a tree. We're going to be doing a whole bunch of classes, and we're going to be using classes we already made in the previous videos. So we're going to need an array list. We're going to be using an array list here. So I'm using IntelliJ. So you can just ignore these comments. I've taken this from an assignment I did in the past. So we're going to need array list, array unordered list. I think we should have already done this. I think I've already, at this point, I will have already uploaded it. We're going to need element not found exception, empty collection exception, non-comparable element exception, unordered list ADT, and maybe an ordered list. Maybe not for this one. But we'll start with the binary tree ADT. So I'm going to create a class here. Right click my src folder, new Java class. Oh, this is going to be a long video, probably maybe like 3 hours or something. So I'll do them in parts. So for this part, we will just be just doing binary tree ADT. So let's create a class called binary tree ADT of generic type T. Got some music in the background. I don't think you can hear it though because these are noise canceling. It's a noise canceling mic. Last time I had music on full blast and it didn't even pick up anything. So that's probably a good thing. So binary tree ADT.java. Hit enter if you're using IntelliJ. So we'll do we're gonna do the interface for this. Actually, sorry, it's an interface. It doesn't really matter though. You can just put interface here. We'll do that. So we'll do public interface binary tree ADT of type T. So this is a tree. A tree has a root. It has a left child and a right child. You traverse the tree in different ways. I think there's like generally 4 ways. We'll talk about it. But otherwise you can just traverse it however you want. But if you want to traverse the whole thing and print it out, there's like special ways to do it. One's like an in-order traversal, pre-order traversal, level order traversal, and I forgot the last one. We'll talk about it. So here we'll just do some comments on the top. We'll say binary tree ADT defines the interface to a binary tree data structure. Param is generic type T, I guess. It did that automatically. You don't have to worry about that. We'll just do we'll do the first method. So we'll do the get root element method. Actually, we can write them first because it's kind of hard to. Well, actually, it's fine. So we'll just say returns a reference to the root element. We'll say at return a reference to the root. So public T get root element. Oh, and by the way, we'll be doing the Android series that will be coming up really soon, finally. Public T, actually I think we're going to be doing XML, so that's also, it's useful in other languages like React Native. So we're going to be learning a whole lot of stuff that's useful. I think C is going outdated now because of Apple switching to Swift. We'll talk about that later. So public T get root element. So it's just going to get the root element. So if it's holding 5, we're going to get 5. So it's like get element from the lists. The link list, link stack, link queue, link deck, whatever. It's like get element except for getting the element that the root is holding. So here we'll have, for the isEmpty method, returns true if this binary tree. Sorry, just fix the mic. So return true if this binary tree is empty, and false otherwise. Let's make this a little smaller, okay. So we'll say at return true if this binary tree is empty. Same thing basically. So returns true or false. It's a Boolean method. So now we'll do the size method. If you're wondering where my mouse went, I'm using 2 screens. I think you can only see one of them. So we'll say return the number of elements in this binary tree. I have a setup that has like 5 screens, but honestly I'm just using, at this moment I'm using 3, but I usually just use 1. Just because I'm making a video, I'll use the extra ones. 5 screens is for like serious trading, but I haven't done that in a while, so we'll just continue with this method. So it returns the number of elements in this binary tree. At return the number of elements in the tree. So public int size. That's it. Next one is contains, so it's just like the contains method in the lists and others if we used it before. It just returns true if it contains the element. So returns true if the binary tree contains an element that matches the specified element and false otherwise. At param target element, the element being sought. Oops, S-A-U-G-H-T, so it just means being searched for in the tree. At returns true if the tree contains the target element. So public boolean contains t target element. So it takes parameter t target element. Is that our first parameter in this one? Yeah, so it's a method that takes a parameter. It's gonna search for this target element. Remember, interfaces have a semicolon after the method. So this one has a lot of methods, mainly because of the iterators. To use the iterators, you have to set it up a special way. So it's kind of a headache. But I guess you have to know how to traverse the whole thing in a certain way. So here we'll do the find method now. Whoops, it uses the find method I think it's a support method, and a lot of them have like doubles. Maybe in the binary search tree. Is this a binary search tree? No, this is just the link tree, I think. What is this exactly? Binary tree ADT. So we're going to have a linked binary tree and then a linked binary search tree. So we're going to be using inheritance. You'll see. So here we'll say, we'll do the find method. So public t find. Public t find takes parameter t target element. So trees are a little tricky to start out with, but the debugging will help you get through it. It's harder than the linked list because each node contains other nodes, so it's kind of difficult, you'll see. But just try to watch a video maybe 5 times or something and you should be able to get it. So this is all taken from the Java Foundation, not all of it, but most of it's taken from the Java Foundation textbook. I think I do create some of my own methods somewhere, so I think this one here, like the toString, return the string representation. You can do it in different ways. I'll show you my way, which works perfectly. So returns a string representation of the binary tree. That's toString. Public string toString. Could we put an override here? Yes, we can. So it's telling us we overrid it. Then here now we'll do the iterators. I think I might have forgot to do the iterators for the list, so I'll try to make that video too. Array list and link list. But they all work the same way. We'll do some examples. So you may get asked that on a test, the iterators, but usually you just have to implement it, the class, and then we'll do some examples. So you just have to create an object reference variable somewhere. Here we're going to do it internally using a private inner class. And I think I do my toString with an iterator, so it does make toStrings easy. So here we'll say returns a string, or no, returns an iterator over the elements of this tree at return an iterator over the elements of this tree or binary tree. So binary tree means it can have 2 children. Each node can have 2 children, and then each one of those nodes can have 2 children. So if it's like a trinary tree, then it can have 3. A quadary tree can have like 4 or something. A septary tree can have like 7. I don't even know what the abbreviations are for 5, 6. Usually they just call it n-ary tree. I'll try to do some notes, but otherwise it's just you can just have a general tree which can have as many elements as you want. But in this one we're just going to focus on binary trees. So I believe a heap is also a binary tree, but we'll go over that after. So here we have returns an iterator over the elements of this binary tree. Then we're just going to call here public iterator of generic type t. Iterator, and it's asking us to implement the class or import. So hit Alt Shift and Enter. And it's the first one, this one. I don't know if you can see it, iterator java.util. Oh whoops, that was the wrong one. Stupid thing. Clicked it. Okay, there we go. Sorry, I just changed the song, it's a really crappy one. Okay, so we'll do the next method. Iterator in order, so these are traversals here. So returns, so it's a tree traversal, returns an iterator that represents an in order traversal on this binary tree. So they're a little confusing to memorize because they work differently. So one does like the left child first, then the root, then the right child, and they do like different ways. But they all keep going down. So they start at the very lowest level of the tree. Or sorry, well, yeah, I guess technically it's the highest level. It returns an iterator that represents an in order traversal on this binary tree. Returns or return an iterator over the elements of this binary tree. So I'll try to get those notes out and correct if all those theories are right. I haven't looked at those notes in a while, so forgive me if I mix them up. But there's a lot of videos to still do, so I'll try to get the notes out. But right now we'll just be focusing on the coding stuff. Maybe some diagrams to help show you how the nodes move. So here we have iterator in order. So we did iterator now. That's just a general iterator. To return an iterator to iterate it however we want to, perhaps. I'll show you an example of that in the toString. And these are special iterators that we're going to create, of course. This one's an override, is it not? I guess not, but it's like a built-in method, I guess. So here, public iterator of type T, iterator in order. So two of them are, so in order and pre-order are a little tricky. The level order and the post order, I believe. Those ones are easy because they just go like top to bottom and bottom to top. I'll try to describe those after. So in order, don't worry about it. You can just debug it to see how it works. So pre-order now also returns an iterator that represents a pre-order traversal on this binary tree, or of this binary tree. I return an iterator over the elements of this binary tree. Public iterator of generic type T, iterator post order. Sorry, was that wrong? Yes, I was. Pre-order, my mistake. Pre-order. So public iterator of generic type T, iterator pre-order. So in order, excuse me, I'm falling asleep here. So in order, pre-order, I'm always falling asleep when I make code videos, aren't I? Just because I've done these codes so many times. And usually I make these videos like late in the afternoon. Oh yeah, it's like evening. Well, with the time change, because the time changed yesterday, so now it's actually 5 p.m. So I'm like starting to fall off to sleep. Even after lunch, I'll be falling asleep. And in the morning too. I'm like always sleepy. So excuse my yawning. So public iterator of generic type T. Iterator post, iterator pre-order. Yeah, so we have iterator, iterator in order, iterator pre-order. And then now we'll do iterator post order. So we'll do returns an iterator that represents a post order traversal on this binary tree. At return an iterator over the elements of this binary tree. So returns an iterator that represents a post order traversal on this binary tree. These ones are kind of repetitive, but at return an iterator over the elements of this binary tree. Then here we'll do a public iterator of generic type T, iterator post order returns an iterator that represents a level order traversal. So this one's a level order one, traversal. So level order traversal on this binary tree. I think that's the easiest one to remember. Returns an iterator over the elements of this binary tree. Public iterator of generic type T, iterator level order. So two of these, I think it's these two. They're completely opposite, but they're really easy. They just go top to bottom and bottom to top, so we'll try to do a diagram of those. So that's it. So now we'll do the binary search tree, binary search tree ADT. Sorry, I'm just looking at my notes here. Just trying to find the next one. So we have this done. We're going to implement it. Where's the next one? Hopefully this screen doesn't go off. Video. So binary tree ADT, we just finished that. Binary search tree ADT. We have a search tree list. I think there's an abstract data for there's an abstract data type interface for that too. We'll go over that later. It's just that's really easy. Once we did all these methods, it'll be easy. Just like a 10-minute thing. All it does, it just creates a list out of the tree. It's just calling methods we already made, basically. So now we'll do binary search tree ADT. This one has a few methods, not as many. So here we're going to use inheritance after we create our class. Sorry, I'm trying to make the other screen bigger. Okay. So here we're going to right click our src folder. If you're using IntelliJ, it should be the same with VS Code, maybe Eclipse. Don't really like Eclipse, as maybe I've said before, because it lags really bad and it's old looking. So binary search tree ADT .java. I think you can use Android Studio for this, but I'm not 100% sure. Public interface binary search tree ADT. Binary search tree ADT.java. That should be right. It should be an interface. Not all compilers will have that option. So here we'll say public interface binary search tree ADT of generic type T, and here we'll use inheritance, so extends binary tree ADT. So we're using inheritance with an interface. It's a little confusing. All we're doing is saying a binary search tree ADT is a binary tree ADT. So binary search tree ADT of type T, you can just put is here, is a binary tree ADT of generic type T. That's all that it says. Or yeah, basically that's all that it says. So here we'll defines the interface to a binary search tree. We don't really need to do that, but we can just try to quickly do it. Binary search tree ADT defines the interface to a binary search tree. Param type T, and here we'll do the add method. We'll do the doc for that, so it adds the specified element to the proper location in this tree. Param element, the element to be added to this tree. Public void add element T element. So we're going to add an element. It just takes a T type parameter element. So we're going to add a type element of type T. So it can change every time. That's why it's T. If it took int, we can only instantiate ints. We can never instantiate a string or a character, for example. So that's why we use T. If you're wondering why. If you're having trouble with generics, don't worry. Just keep practicing. It's not that hard. If you just keep writing, even if you don't know and you just write them, that's how I learned. I didn't really know, but I just kept writing them till it just becomes like normal. You'll get used to it. So here we'll put removes and returns the specified. Oh, and by the way, we don't really ever use wildcards and all that. Raw types maybe you'll use, but most of the time you don't need all that stuff. In most cases. Because that stuff isn't in, I don't know if it's in all languages, but usually generic types are. And raw types maybe, probably. But definitely just the way that we're going to use them that's about it. Sometimes they'll put a generic type in a generic type. I haven't seen 3 of them in one. Usually maybe just one in another one. That might happen, and you'll also be able to do those naturally eventually too. Sometimes you can't explain it, but you just do it you could just do it on the fly. So removes and returns the specified element from this tree. Param target element. The element to be removed from this tree. Return the element to be removed from this tree. So this is a remove method. Remove element. Return the element to be removed from the tree. Public T remove element takes parameter T target element. So we're going to remove the target element that we're going to pass this parameter. So we're going to pass a parameter here, and we're going to remove that one. That's it. I was going to say something, but I forgot. That's okay. If I remember, I'll let you guys know. So removes. So now we'll do remove all occurrences. So removes all occurrences of the specified element from this tree. Param target element, the element to be removed from this tree. Remove all occurrences, so public void remove all occurrences. I think this is spelled right. T target element takes parameter T target element. So I think 3 of these methods I did myself. I'll show you. They're not too hard. One just uses a simple traversing technique similar to if, like, let's say in an object reference variable temp points to head, like linear node of type T, head points to head, right? Then we say while head dot get next is not equal to null. We're going to do something similar here. We're going to take a binary tree node of type T. We'll call it temp. We'll point it to root. Then we'll say, well, like if we're trying to find the min element, then it's going to be on the left, because each tree, if you don't know what a binary tree is, oh yeah, I remember I was going to say now, but if you don't know what a binary tree is, the minimum element is on the bottom, it's on the left side of the, so if you take the root, the minimum element's going to be on the left, the maximum element's going to be on the right, so the element less than the root. So let's say the root's 10, then element 5 will be on the left, and the element 14 will be on the right. If you add a million, it's going to be on the right, and if you add negative 10, it's going to be on the left. And what I was going to say is that when I said I forgot, that most of the videos on YouTube, like when I was learning, sometimes I looked for stuff that I was learning to, if I didn't understand it. I never saw them do videos with generic types. Every time I see a video, it's usually non-generic. So it's good to practice generics because other languages use them too. And it's actually more advanced. Generics are, and actually they're an advanced topic in programming. So if you know generics, it's better for like an interview and stuff, or like just a project. If you're like a manager or something, if you're managing your own stuff, you can work with other coders who use generics too. So maybe it could probably help you. So public, because other languages use them too, so it'll help. So public, so here we have public void remove all occurrences, T target element. So here we'll say removes and returns the smallest element from this tree. Oh yeah, and to traverse it, it's just while, if we're trying to find the minimum element, then once we create that reference variable, then we say while temp. Oh, then we're gonna have to, well, not for remove, yes. For a find, we just need one. We'll say while temp dot get left, which means get left child. So while temp dot get left does not equal to temp, then temp equals to temp dot get left. So it's going to keep traversing till it gets to the last element, which its next child or whatever, its left child is going to be null. Then it'll return us the minimum. So it's not that hard. But that's only to traverse one way. And of course there could be well, if you're looking for an element between the minimum and max, there's many branches. But if you're just looking for min or max, it usually should just be that way, with a while statement. You can maybe do it with a for too. So here we'll say removes and returns the smallest element from this tree. Then here we'll say public t remove min. So with a remove, you'll have to create a parent object reference variable and point it to our temp. And then when we traverse, we'll have to first point parent to temp and then set temp point to temp.getLeft. Then every time it iterates, it's going on. If once it's null, then that parent won't point to that next element. The last one is going to point to the second last one. Therefore, if we're removing, we're just going to remove that element, and then by setting the second last left child to null. So you'll see, we're going to nullify it. So public t remove min. Then here we'll say removes and returns the smallest element from this tree. At return the smallest element from the tree. Public t, sorry, did we already? We'll just delete that one. So removes and returns the smallest element from this tree. Return the smallest element from the tree. Public t remove min. So public t remove min. Then here we'll do the opposite, removes and returns the largest element from this tree. Return the largest element from the tree. So here we have public t remove max. And we'll have find min and find max. So it's the same thing, we're just going to find the min and then instead of removing it. So therefore we'll just need one object reference variable. So here we'll say returns the smallest element in the tree without removing it. At return the smallest element in the tree. Public t find min. Public t find min like that. Then here we'll have the opposite again, so returns the largest element in this tree without removing it. So it's kind of like first and last, or peak. It's like that. It's just finding it. It's not modifying anything. So here we'll say I return the largest element in the tree. Public t find max. So that should be all. So create a class called BinaryTreeNode. Let me just find my nodes for that. I think that's what should be it. BinaryTreeNode. For now, just start creating that class. Yeah, it's called BinaryTreeNode. Okay, so you can excuse that if you can see that. It's my comments for my assignment. Okay, so I'm just gonna change the song by the way while you're creating that. Let's see what's here. Binaural. Can I get some? Sometimes I listen to alpha waves. They help you like be more innovative. I have some like really old ones. They still work. Oh, not this one. That's fine. Okay, so we'll just go with that class. So right click your src folder, BinaryTreeNode .java, and I think that's it. I'll just double check for interfaces. Main binary tree search. What do I have in here? List ADT we don't need. Well, we do, but we've already done all that stuff, I believe, so we don't need that. Binary search tree ADT we're done. Binary tree ADT we're done. Yeah, so now we'll do so there's 3 classes here to do. One of them's really long. That's the one we're gonna do. After this one. So this one's easy. It's quick. Should be quick. It's a little longer than the node classes we originally made. It may have like a recursive method called numChildren. We're not going to go through all of them, such as that one, because that's really long. I've showed you in the other video how to do some recursion. Hopefully I posted that. Or, yeah, by the time I post this. We just do it the same way. So here we have public class, binary tree node of type T. We'll just do a little doc here at the top. So binary tree node represents a node in a binary tree with a left and right child. Just gonna grab some water real quick. Okay, so every binary tree node object has 3 fields: T element, binary tree node of generic type T left, object reference variable, and binary tree of generic type T right has a binary tree object reference variable right. So it has a left and a right binary tree node of generic type T object reference variables. We're going to instantiate them. We're going to have, I think, 2 constructors. We could have had 3, but we're just going to have 2. So we're going to have some fields here, as we just said. So it's going to be protected. Not sure exactly why they're protected, but that's fine. So protected T element. Through I know why it's like through inheritance, but I don't even think we extend binary tree node. Might be a mistake, but that's okay. It still works. I've already tested it. So binary tree node of generic type T left and protected binary tree node generic type T right. Here we'll have our constructor 1. I'm going to overload them, so we'll say creates a new tree node with the specified data. At param element, the element that will become a part of the new tree node. Excuse me. So public binary tree node t takes parameter t element, really use this keyword, so this dot element is set equal to the parameter element, left is set equal to null, right is set equal to null. I thought there was two constructors. Maybe not. We just have one. We could have also set an empty tree node. We could have maybe set it without an element. But that's okay, we don't need to do that. You can do that for fun or for practice. Just do the same thing without it with a parameter. Do the same thing without a parameter. So element will be set to null as well, or whatever you want. Most likely null if it's empty. Or if you really want, you can get them to hold like 2 or 3 elements, whatever. Maybe a string and a number, something like that. Username, password, whatever. So here we'll, okay, actually there is another constructor, that's what I thought. So this one's going to, it's a little tricky. I don't even think we use this one. But it's going to take a linked binary tree object reference variable. I don't think we use this one, but we'll just do it anyways. So it creates a new tree node with the specified data. That would be a good keyword for a programming language, with. I don't know why, but it just seems like it would be. So at param element, the element that will become a part of the new tree node. At param element, the element that will become a part of the new tree node. So we got element, and then at param left, the tree that will be the left subtree of this node. So it's going to have a subtree. At param right, the tree that will be the right subtree of this node. So public binary tree node takes parameter t element, and then a linked, it's going to have a error for this. Linked binary tree of type t left, and a linked binary tree of generic type t right. Don't worry about this right now. We don't even need it. I'm just doing it so we don't have to do it later. So it doesn't know what linked binary tree is because we haven't done it. We're going to do it after this one. So we'll say this dot element is equal to element again. We'll say if left is equal to null. Whoops. This dot left is set equal to null, so it's going to say, okay, this object reference, or sorry, this instance data left is going to be set equal to null then if the parameter left is null. That's all that it's saying, if you're confused. So else this dot left is equal to left dot get root node. So else if left is not null, if our parameter left is not null, then this dot left, then this instance data left is equal to left parameter dot get root node, which I don't think we've done that method yet. We will. I think we're about to do that method. So perhaps we should have come back and done this one after. But all it's gonna do is just get our root node, and I can't find it. Actually, that's gonna be in binary tree. Yes, because it's left dot, so it's saying link binary tree left dot get root node. Don't worry, we'll get there. Actually, maybe we should just come back to this one. Might be, well, then we might forget about it. So we'll just leave it. We'll come back. We'll try to come back. So this dot left points to left dot get root node. So this is just a method, just gonna return the root. That's all it does. Actually, you can just say get root if you really want to. It's easier to change it. I found it easier to just say get root, like get head, instead of get head node, but it doesn't really matter. So get root node. So all it's going to do is just return the root node. Just going to say return root. That's it. And it's going to be an object reference variable. Then here we'll say if right is equal to null. Then we'll say this dot right is equal to null. So if right, so it's saying if the right parameter is equal to null, then this dot right, which means it's accessing the instance data right, then it's going to be set, the instance data is going to be set to null. Else this dot left. I would have done these with brackets, by the way, so then I wouldn't need to space them out. Else this dot right is equal to right dot get root node. I guess this programmer isn't used to that, but I find it easier. Like if we were to do this, not like that, but like this, and then done else, like that. I think maybe overall it does use more lines, but it helps you quickly find the statement associated with it. So perhaps it is easier for some people like me. Anyways, we have if right is equal to null, this dot right is equal to null, else this dot right is equal to right dot get root node. Excuse me. So we'll have the recursive method here. This one, it's really long, especially if you have like 10 elements. You might have like maybe like almost 20 different iterations, so it could, or more. So returns the number of null children of this method. Sorry, of this node. I don't know why they did it this way, by the way. We should have had a count somewhere. It would have been so much easier. It seems like you could have a count. And all it is just adding here anyway, so kind of silly. I'm sure you could do the same thing with a count. So int children is equal to 0. If left does not equal to null, then children equals to 1 plus left.num children. See, it equals to 1 now, so it just all it's doing is adding. So I don't know why they did this. They could have just on every add just incremented and a count, and on every remove just decremented. So much easier. Children equals 1 plus left.num children. If right does not equal to null, children equals to children plus 1 plus right dot num children. Return children. So it's an int, and I forgot our method header. So I'll do public int num children. And that's it. So it returns an int. Here we have an int, and it just adds them on every iteration. It's dumb. It's slow. We could have just incremented it ourselves, so that's fine. You can change this, by the way. We can even maybe change it to just add a count for fun and get rid of these counters. So here we'll have get element. We'll do a few getters and setters. I think one of them I created myself. Just a setter, I know, but for some reason they didn't include it. Usually they skip methods too in the Java Foundations textbook. So here we'll say return the element of this node, or at this node. Return the element, maybe say in this node. Return the element stored in this node. So public t get element. Whoops. Return element. You can say this dot element if you want, but you don't need to. Here we'll do a set element. This is the one I created. There's no doc for this. I mean, we could create a doc. We could just say, whoops, what's happening there? Sets the element in this node at return nothing. So we don't need a return, doesn't return anything. It's a void. You could do at return void. So we'll say public void set element t element, takes parameter t element, then just set this dot element to element, parameter element, element to element, element, okay. Just a few more. Actually, maybe a few times 2 or 3 more, but just small methods, like one-liners mostly. So we'll say return the right child of this node. Return the right child of this node. Public binary. So this one takes a public binary tree. It returns type binary tree node of generic type T. We'll call it get right. So it returns right. Why does it return binary tree node of type T? Well, because above here we're setting it as an object reference variable, but it's of type binary tree node of generic type T, so that's why we have to return binary tree node of generic type T. So that's a little confusing because we're not saying void, we're not saying T even, we're not saying int, we're not saying string because we're not returning a T, an int, or a string. We're returning a binary tree node of type T. So we've created this object reference variable ourselves. So when we use them, you'll see. But it's just something to just practice. It's hard to explain sometimes. Just think of it as just an object reference variable we've created, and we're going to use it the way we need to use it. So get right, we're going to have a set right. So just going to return the right child of this node, and then we're going to set the right child of this node as well with a setter, or a mutator. So sets the right child of this node. Param node the right child of this node. Public void set right. What happened here, by the way? Oh, I have a bracket here. Public void set right. So binary tree node of generic type T. Node, we'll call it node. Then here we'll set right point to node. So here we're just saying our right instance data points to the parameter node. That's it. Here we'll do the accessor for get left. So we'll just say return the left child of this node. Return the left child of this node. So public binary tree of generic type T get left. What's happening here? Binary tree node, sorry. Binary tree node of generic type T. Binary tree node of generic type T get left. And then we'll just say return left. That's it. We'll do a set left and a toString. So here we'll say sets the left child of this node at param node the left child of this node. I think we're going to use all of these, get left, set left. So remember, like when we traverse, I said get left and get right, so that's what's going to happen. It's just basically going to return us a memory location, I think, and that we just use it to traverse. So like our example was, we create a binary tree node of generic type T, we call it temp, we point it to root, right? Then we say while temp dot get left, which is just going to return us the left child of the node, does not equal to null. Then we'll set temp pointing to temp dot get left. So that's all. It's just, I think internally it's just returning numbers, like memory numbers, small numbers like 3 or 4 digit numbers. But all it's doing is just passing the nodes around. So we'll do that in the debugger after. So here we'll just say public void set left, and it takes a parameter binary tree node of generic type T, and we'll call it node. And we'll say left points to node. That's it. And then we'll say we'll do the last one, public string toString, and then we'll just return element dot toString. So we're just going to call the internal toString method instead of setting it up in a harder way. We'll just call the internal method, which is just going to return our element. It's going to automatically detect the type, string, a number, whatever, and it's just going to convert it to a string from the hash code. We can put an override here, so add override. And that's it. So it's been an hour now. going to take a little break and I'll come back. So I'll be back.